Hello everyone, this is Stuart from N4L, and today I'm following up on a previous video I made explaining the use of a selectable filter in our PPA analyzers to achieve similar measurements to that of other products with a different bandwidth. In that video I used harmonic measurement modes so we could look at harmonic components of an applied square wave voltage. In this video I'll use the same applied voltage and the same filter in both RMS and power modes, so it's clear that good measurement correlation is achieved in all modes that engineers will commonly use. I've got the oscilloscope mode initially so you can see the voltage applied, and you may have noticed as I was talking in here that there are some overshoot events that are occasionally appearing because you have a limitation on the sample display or the pixel display on an oscilloscope screen. But if I go into the RMS mode, it's a really good way to illustrate the benefit of the faster sampling that you get on a PPA analyzer, because you can see the peak value, that's the overshoot now, not just as a stable magnitude, but also with polarity, so we show the direction of the peak as well as the magnitude of the peak. And that fast sampling is maintained in all the main power measurement modes, and we have here on the standard display watts, volts, amps and frequency. And as before, you can remember that we have selectable zoom functions that we can control with a cursor, but I'm just going to use the standard zoom functions that the instrument will power up with, because that includes the two values I'm comparing with the Voltec here. Now if we go down to the 100 Hertz that we started at in the previous video, you can see that we're maintaining synchronized frequencies, and the 9.98 voltage is the same as we had before, and the 10.005 is the same as we had before on the PPA at that frequency. So we're getting good correlation at low frequency. And when we go up to a kilohertz again, we start to see that that voltage is maintained, the PPA is maintaining that, and the Voltec is starting to fall off. And if we carry on up to 10 kilohertz, which we did before, there we are, 10 kilohertz, we're still maintaining 9.97 nominal voltage on the PPA, but we've gone down to 9.123 on the Voltec. So we're seeing the same effect that we saw in harmonic mode. You don't have to be in harmonic mode to see that. And you can go straight in and switch on the default 40 kilohertz filter that is typical with many power analyzers, and it shows that the value is much closer to a typical narrower band analyzer. And I can take that further, so I can go from 40 kilohertz, for example, to 38 kilohertz. So let's bring that filter down, which I did before, and you see now we're getting closer still. And this can carry on where you can just use the user selectable frequency to increase the filtering effect until we get comparable numbers, which you can see there. And now we're illustrating good correlation between two instruments that now have a similar bandwidth. And if I go back down to 1 kilohertz, you'll see that while not exactly the same, we have good correlation. Two instruments with different hardware and different sampling are never going to be identical, but now we've got correlation within fractions of a percent. And if I carry on going down to 100 Hertz again, you see that that correlation remains good. This has gone down a little bit from before because that RMS value has got reduced bandwidth on it. So that's why we're now a little closer to the Voltec. But you can see that by using that function, which you can easily switch in and out, I can look at wideband or I can look at simulated values to get good correlation with other products. I hope that's helpful. Thank you very much, and bye for now.